MIT researchers have invented a way to integrate breadboards directly onto physical products. The aim is to provide a faster, easier way to test circuit functions and user interactions with products such as smart devices and flexible electronics. Breadboards are flat platforms widely used for electronics prototyping. They are rectangular boards with arrays of pinholes drilled into the surface. Many of the holes have metal connections and contact points between them. Engineers can plug components of electronic systems from basic circuits to full computer processors into the pinholes where they want them to connect. Then they can rapidly test, rearrange and retest the components as needed. But breadboards have remained that same shape for decades. For that reason, it is difficult to test how the electronics will look and feel on wearables and various smart devices. Generally, people will first test circuits on traditional breadboards, then slap them onto a product prototype. If the circuit needs to be modified, it is back to the breadboard for testing and so on. In a paper being presented at CHI, that is Conference on Human Factors in Computing Systems, the researchers describe curve boards, 3D printed objects with the structure and function of a breadboard integrated onto their surfaces. Custom software automatically designs the objects, complete with distributed pinholes that can be filled with conductive silicon to test electronics. The end products are accurate representations of real thing, but with breadboard surfaces. Curve boards preserve an object's look and feel, while enabling designers to try out component configurations and test interactive scenarios during prototyping iterations. In their work, the researchers printed curve boards for smart bracelets and watches, frisbees, helmets, headphones, a teapot, and a flexible wearable e-reader. To validate the curve boards, the researchers printed a variety of smart products. Headphones, for instance, came equipped with menu controls for speakers and music streaming capabilities. An interactive bracelet included a digital display, LED, and a photoresistor for heart rate monitoring, and a step counting sensor. A teapot included a small camera to track the tea's color, as well as colored lights on the handle to indicate hot and cold areas. They also printed a wearable e-book reader with a flexible display. In a user study, the team investigated the benefits of curve board prototyping. They split 6 participants with varying prototyping experience into 2 sections. One used traditional breadboards and a 3D printed object, and the other used only a curve board of the object. Both sections designed the same prototype but switched back and forth between sections after completing designated tasks. In the end, 5 of 6 of the participants preferred prototyping with the curve board. Feedback indicated the curve boards were overall faster and easier to work with. But curve boards are not designed to replace breadboards. Instead, they would work particularly well as a so-called mid-fidelity step in the prototyping timeline, meaning between initial breadboard testing and the final product.